Hi everyone. So in this video we are going to see about the case study on computer and storage cloud. So imagine a university where students can access a lab software from home. Researchers can run a heavy AI models without special hardware, and administrators can manage everything from student data to finance securely anytime and anywhere. So this is possible only when a university moves from a traditional data center to a cloud-based compute and storage system. Today we explore how universities are transforming into modern cloud-first campuses, enabling fast learning, powerful research and seamless administration. So why universities need cloud now? So traditional servers are costly and hard to maintain and fail during peak workload. As a real-time example, during admission season, thousands of students log in at once and old servers crashes. Engineering labs need high-end computers, but most students cannot access them from home. Research scholars require GPUs for AI, ML and simulations, very expensive to buy physically. So cloud solves all of these, that is 24/7 access, no hardware purchase and pay only for what you use and scale instantly during exam results, admissions or project submissions. So a 2025 EduTech Global report says that cloud-based universities perform 40% better in digital services. Cloud deployment models. So universities choose from three main cloud types. First one is the public cloud. So ideal for learning management system, that is LMS, and online classes and faculty portals. For example, Google Workspace, AWS Educate, Microsoft 365. Next one is the private cloud. So used for sensitive data such as examination systems, student records and financial data. For example, IIT Bombay uses an internal private cloud for confidential research and exam data. Third one is the hybrid cloud, so best of both. Sensitive data stays inside campus, other workloads go to AWS, Azure or GCP. Example, UCLA uses hybrid cloud, internal servers plus public cloud for analytics. Core cloud service providers for universities. So universities use four major cloud services. IaaS, that is nothing but infrastructure as a service. So universities get virtual machines, storage and servers. For example, AIML labs use cloud GPUs instead of physical GPUs. PaaS, platform as a service, so used for student projects and research apps. Example, students build apps using Azure App Services, Heroku and Google App Engine. SaaS, so software as a service, so cloud applications such as Canvas, LMS, Zoom, Google Meet, ERP systems like attendance, fees, library, everything is monitored there. And serverless computing, so used for irregular workloads. Example, during exam results, the system auto scales and goes back to zero usage after workload. So architecture design. So let's break the architecture into two layers. First one is the front-end layer. It includes student portal, faculty dashboard, research data portal. For example, a student logs into the check attendance, gets a personalized dashboard from the cloud, and in the backend layer, it handles virtual machines, storage clusters, network security, and identity management. For example, a researcher uploads 500 GB genome data, backend storage saves, replicates, and protects it. Compute resources. So universities need different types of computing. So first one is the VM types. So general purpose VMs for used for student projects, and compute optimized VMs for simulations, memory optimized VMs for big data analytics. For example, AIDS labs running Python and Jupyter notebooks on cloud VMs instead of physical PCs. HPC clusters. So high performance computing clusters support climate modeling, deep learning, chemical simulations. Example, UT Dallas and TAC provide HPC for students across the US. Cost optimization. So cloud gives pay as you go. For example, AI projects require GPUs only for 2 to 3 hours. So pay only for that time. So storage solutions. Cloud storage adapts to university needs. So tiered storage. Standard storage for daily used files. Nearline for monthly access files. Core lines, yearly access data. Archive, old research data. Example, PhD data from 2015 stored in archive tier at very low cost. Next is the redundancy. So LRS means stored within one campus region. ZRS stored across multiple zones. Example, exam answer scripts stored with ZRS to prevent data loss. So real world university or cloud implementations. Many universities already use cloud based systems. AWS Education Cloud used by Harvard, MIT and Stanford for teaching and research. Texas Advanced Computing Center, that is TAACC, provides national level HPC for genome studies and physics simulations. Hybrid cloud at UCLA. So sensitive data stays in private cloud. Analytics and ML run on public cloud. So these examples show how cloud accelerates innovation. So challenges and plus future vision. So universities face challenges, that is governance. So need rules for data privacy. For example, exam data must follow regularity and guidelines. Second one is the skill development. So invest in a comprehensive training program for IT staff and end users. Next is the cost management. So implement a robust monitoring system to track the usage patterns and prevents the unexpected expenses. So the future, empowering universities with cloud first data centers uses the flexible infrastructure and innovation enablement and universal access. Thank you.